Hi, we're in lesson 5.2 today, and you can see from the title that we're going to talk about using simulation to estimate probabilities. Folks, a simulation is just putting mathematics to work for you to model a real life situation without having to actually do the real life situation. You make up some kind of a plan that will let you mimic what happens in real life. So we did this earlier in the class. You may remember in the first week even, we simulated selecting 3 workers to lay off from a group of 10, and we were thinking about their average ages at that time. Today we're going to look at two different approaches to conducting a simulation like that, but both of them use random digits. As we are going through our simulation today, we're going to be outlining a 4-step model for conducting a simulation. For those of you who are taking the AP test, this is going to be an important thing for you to remember. Our textbook contains a page, folks, that's taken from a book, believe it or not, of random digits. So somewhere, someone has published a book that has page after page after page of random numbers. So just numbers 0 through 9 in no random pattern, probably done with a computer model. And I've heard some arguments that maybe that's not as random as we suppose, but it's random enough for us today. This is just a part of a page of a random digit table. And I'd like us to use this thing to simulate rolling a dice, really that should say a single die, 25 times to estimate your chance of rolling a 6. Now mathematically, we know what should happen. Say 6 is one of 6 possible outcomes on the die, so 1/6 of the roll should come up to be a 6. However, when we actually do that experiment, it may or may not happen that way. So, to begin talking about our simulation, we want to state the assumptions that we're operating under. And if we are using a table of random digits like this to simulate rolling a die, we are assuming that all 6 outcomes are equally likely. That is, we're not using a loaded die. Ours is fair, and all 6 outcomes are as likely to come up, each one is as likely to come up as the other. So all 6 equally likely. The second step is to describe the model that you're using. So you want to tell the reader how you're going to use those random digits to conduct one trial. That just means one repetition of your simulation. And if we're using a random digit table, this is what we must say. We're going to use the digits 1 through 6 to represent the faces of the dice. So use 1 through 6 to represent the faces on the die. From a random starting point. And that's very important here. If we're really using the random digit table the way that it's designed to be used, you have to pick a random starting point. So I always tell people, close your eyes, move your pencil around the page, and select a spot to start. And I picked that 7 right there. From a random starting point, check the number to see if it's in the range that you need. So we want to see if it's in the numbers 1 through 6. If so, you've got your first number. If not, move to the next digit and repeat until you do get your first number. Alright, so I want to go back up to my spot in the random number table and see, okay, 7 does not work, so that number is no good for me. The next number is a 0. That also does not work. However, here I go. I've got my first number, and my first number was a 4. Okay? So we've described the model that we're using. Next, you actually do the simulation. You run the simulation a large number of times. Remember the law of large numbers, right? We're supposedly doing this 25 times, but if we wanted a better simulation, 1,000 times would be better. And why is that? Well, I just said it. It's the law of large numbers. Right? The more often we do it, the more frequently what should happen will happen. And then in step 4, you write a conclusion. So our conclusion would say, in my 25 trials, I got a 6, and then it's however many times. So my probability of rolling a 6 was, and then it's however many you got over 25. So you want to write a sentence that concludes what your experiment was. You should be talking in terms of the context. You were rolling 6s. You weren't picking numbers from a die or from a random table. You were rolling 6s. So you got to talk about it in those terms. The same thing can be done using your calculator, and some of you will remember that's how we did this at the start of class. The calculator keystrokes to get 25 integers between 1 and 6. If you're using an older calculator, an 82, so on a TI-82, what you would have to do is, it's the int function, which is found under math, then we're rolling a dice, so 6, then it's the rand function, which is also under math and probability, plus 1. This will get you a number between 1 and 6. You'd have to repeat that 25 times, keeping track of the number of 6s. On an 83 or 84, folks, they've included a function that makes this much easier to do. It's under math and probability, and it is the rand_int function. Rand_int. You'll find that under math and probability. The way it works, start number, end number, so I want numbers between 1 and 6, and then the number of repetitions that you want. We want 25 in this case. So again, that 1 starts with 6. That's our ending number because there are only 6 possibilities on a dice. And then the 25 is the number of repetitions that you need. Alright, let's move on. And we're going to talk about setting up a simulation for this situation. This comes from your textbook. A catastrophic accident is one that involves severe skull or spinal damage, which is kind of sad. The National Center for Catastrophic Sports Injury Research reports that over the last 21 years, there have been 101 catastrophic accidents among female high school and college athletes. 55 of these, so more than half, resulted from cheerleading. Suppose you wanted to study catastrophic accidents in more detail. You take a random sample without replacement of 8 of these 101 accidents. That without replacement just means if I select an accident, then I'm done with it. I can't pick it again. Estimate the probability that at least half of your 8 sampled accidents resulted from cheerleading. Now, we are to describe a simulation using random numbers that would model this situation. And folks, we said that there are 4 steps to model or to describing that simulation. The first is stating the assumptions that you are making. And folks, if we are using random numbers, that means that the accidents themselves are unrelated. The accidents are unrelated, or another way of saying this, any cheerleader is equally likely to have such an accident. And I know some of you are saying right now that's not really true because flyers are more likely, but for our simulation, any cheerleader is equally likely to have an accident or to have an accident like this. Alright, and that's our assumption here. If we're using random numbers, then we are assuming that it could happen to anyone. The second step in describing a simulation is to explain how you're going to use the numbers. So this is a little different from what we've done. We don't want 1 in 6 chances anymore. 55 out of 101 is what we want. So we're going to use numbers 1 to 101, letting 1 through 55 represent or equal had an accident, actually a catastrophic accident. It is not necessary. They want you to describe it in words. You could at this point talk about the calculator keystrokes that you're going to use. I'm going to use, since I have the TI-84, RandInt. And then what I would have, numbers 1 to 101. And I need, well, this says I'm sampling 8 at a time. I need 8 repetitions. I'm going to count the number of catastrophic accidents. Notice we want to talk about this in terms of the context. We're not talking about drawing random numbers. We're talking about catastrophic accidents. All right, this has already been done, and you'll see on the next slide 990, a table of 990 trials of this. We're going to do, this says 10, and add our results to the table. I am going to do 1 so that you can see what I'm doing, and then I'll go ahead and finish my 10 trials and we'll recap. So I've hit my math key, I'm down in probability, and there's the RandInt function I want, number 5. It's start, ending number, and number that I want like that. So I'm asking it to select me 8 numbers out of this range. If I have a repetition, I'm going to have to go again because you can't have repetition in this particular simulation. Once we choose an accident, it's chosen for good. I'm counting the number of accidents that are catastrophic. That means anything between 1 and 55. So I'm going to ask you guys to count with me. I have 1 at 31, 2 is 26, 3 the 5, 4 is 12, and that's it. So I got 4 out of my 8, okay? And I'm going to just tally here that I had 1 more like that. I'm going to complete 9 more trials. I'll catch up with you in a minute. I've done my 10 trials and I've tallied them up here. I have to add them into the total. So let's see, we have 81 and then 187, the number of times that 3 of my 8 numbers were within the range 1 to 55. I had 4 times it happened 4, so let's see, 259 and 4 is 263, 252, 161, and then I didn't have any trials that had 7 numbers or 8 numbers. My conclusion, well, this is going to help me. I'm asked to find the probability that half or more of my accidents were cheerleading accidents. So based on the results of this simulation, that happened 263, 252, 161, 43, and 3 times, 722 times. Okay, the probability that 4 or more of the accidents were cheerleading accident. That would be the number of samples with 4 or more that fall into that category over the total, 722 out of 1,000 times. So my conclusion needs to talk about the probability, and it wants it in terms of this is, by the way, that's our 4th step in the simulation. We give our conclusion. 722 out of 1,000 such accidents in our simulation came from cheerleading. So there we've done our simulation. So to recap, 4 steps in a simulation. The first is stating the assumptions that you're making. The second is model. The third is do repetitions, many of them, the more the better. And the fourth is writing your conclusion. Ladies and gentlemen, we'll see you in school. Get out there and do that. You try.